While the Moon and the Earth are relatively the same distance from the Sun, they differ dramatically in temperature. The lowest temperature ever recorded on Earth was -89 degrees Celsius, and the highest ever recorded was 71 degrees Celsius. In contrast, on a daily basis, the Moon fluctuates between -170 and 100 degrees Celsius. So what causes this difference? Well, you might be familiar with the term greenhouse effect. What you might not know is that this phenomenon allows life as we know it to exist on Earth. So how does it work? The greenhouse effect is caused by 5 major gases in Earth's atmosphere: water vapor, carbon dioxide, methane, nitrous oxide, and ozone. In general, these gases shield our planet from violent energetic rays, while during the night they trap infrared radiation to maintain the planet's biologically friendly temperatures. Water vapor enters the atmosphere through Earth's water bodies, so humans do not directly play a role in its atmospheric presence. Not so fast. While humans have not directly increased water vapor levels, they have increased through our contribution to global warming. This process is called the positive feedback loop. As factories release greenhouse gases like carbon dioxide into the atmosphere, the Earth warms. This warming enables water vapor to evaporate and enter the atmosphere. This cycle is accelerated by deforestation, which decreases the planet's ability to control carbon dioxide levels. Water vapor contributes most to the greenhouse effect, averaging between 36 and 70%. Carbon dioxide enters the Earth's atmosphere as humans burn fossil fuels, gas, coal, and oil. While it does not contribute most to the greenhouse effect, it contributes most to global warming. In 2007, the IPCC released a global assessment of the relative influence of atmospheric aerosol gases on global warming. With by far the largest RF value, the profound impact of carbon dioxide on the Earth's atmosphere was revealed. Studies have also revealed the tendency of carbon dioxide to remain in the atmosphere for prolonged periods of time. This carbon dioxide determines not just the climate today, but the climate which will remain for generations to come. As a whole, carbon dioxide causes 9 to 26% of the greenhouse effect. Methane, another major greenhouse gas, is created through the decomposition of waste and manure. Thus, an increase in the cattle industry has contributed to rising levels of atmospheric methane. In addition, methane is one of the most powerful greenhouse gases. While carbon dioxide is more abundant, methane contributes most to the greenhouse effect per molecule. In all, methane is 84 times more powerful than carbon dioxide. Nitrous oxide, another greenhouse gas, is created naturally and artificially. Some sources include soil cultivation, organic fertilizers, consumption of fossil fuels, and the production of nitric acid. Finally, ozone is produced most commonly in the stratosphere when solar radiation strikes oxygen, as shown in step 1. This causes oxygen molecules to split, leaving 2 free atoms. When these atoms collide with other molecules of oxygen, ozone is created. The highest levels of ozone are found in Canada and Siberia, while lower levels are found around the equator. Overall, ozone causes between 3 and 7% of the greenhouse effect. So now we know what greenhouse gases are. How do they maintain the Earth's relatively stable temperatures? In order for greenhouse gases to absorb electromagnetic radiation, they need electrically charged particles. However, most of Earth's atmospheric gases do not possess an electric charge because they have a balanced number of protons and electrons. Thus, polar molecules enable this function. Water vapor is a polar molecule because the electrons are unequally shared between the hydrogen and oxygen atoms. Atmospheric gases which are electrically lopsided include water vapor, ozone, and nitrous oxide. So what about the two other major greenhouse gases, carbon dioxide and methane? While neither exists in a polar state, they both manage to absorb radiation. This is because gas molecules remain in constant motion, crashing into each other billions of times per second. This allows both to absorb infrared radiation and therefore warm the Earth. Why does the greenhouse effect matter in our everyday lives? Since the beginning of the Industrial Revolution, humans have contributed to the greenhouse gas concentration in the atmosphere, and the effect hasn't been entirely positive. Most scientists now agree that human expansion is a direct contributor to an increasing greenhouse effect and to global warming. The melting of glaciers and rising sea levels are some of the effects of global warming. If the trend continues, some major port cities like New Orleans and Miami will be submerged in water by the year 2100. How do we reverse this? Recently, 196 nations have signed a pledge to reduce greenhouse gas emissions. The goal of the group is to prevent temperatures from rising above 1.5 degrees Celsius in the coming years. However, even with these measures, a rise in just 1 degree Celsius poses a threat to coastal cities around the world. So what can we do as a population to protect our planet? Buying energy-efficient products, conserving energy, planting trees, reducing, reusing, recycling, and making climate-friendly transportation choices are a few things. Above all, the most important thing is to stay informed and learn how to care for the planet where we live.